Hello, students. Today, let us solve some of the past paper type problems on the application of equations of motion to the vertical motion. Last time we have seen that in vertical motion, the acceleration remains constant if we neglect the air resistance, and hence we can apply the SUVAT equation. So let us do some of the problems on this. So come to the first question here. A stone is projected vertically upwards. Mark the important things. From the top of a cliff, 10 meter above the ground, with a speed of 15 meter per second. Find the greatest height above the ground reached by the stone and the time of flight. Now the time of flight is the total time the stone will take to reach back to the ground. So let us come to the first part here, and let us make a sketch. So suppose this is the cliff which is 10 meter high. The stone is projected from the top of this with a speed of 15 meter per second. So it will go to the maximum height and come back to the ground. So what things are given to you? Note the data with the proper symbol. The initial velocity is given to you. U is 15 meters per second. Obviously, when the stone will go to the maximum height, what will be the velocity? The velocity will be 0 because the stone will become stationary. And since in the vertical motion, as we have already discussed, the stone is decelerating, so A will be taken as negative 9.8 meters per second square. You want to find out the greatest height. That means you want to find out S. So, which is the best suited equation to solve this, which gives the relationship between U, V, A and S. Keep it in mind that we don't have T here. So, obviously we'll use V square is equal to U square plus 2AS. V square is 0 square, U square is 15 square, plus 2 into negative 9.8 into S. So that means S is equal to 15 square upon 2 into 9.8, which will come out to be 11.5 meter to 3 significant figures. But be careful, we don't want the height reached by the stone from the top of the cliff. We want from the ground. That means we have to add this 10 meters to it. So the greatest height reached by the stone above the ground will be how much? It will be 11.5 and plus 10 because the stone is projected from 10 meter above the ground. So total height will be 21.5 meters. Now let us come to part B. You want the time of flight. Here, keep it in mind that again the stone is projected from the top of the cliff. It goes to the maximum height and comes back to the same level. So vertically, what will be the displacement of the stone? It is coming back to the same level. That means the displacement is 0. And now it is traveling downwards 10 meters. That means total displacement of the stone in this journey will be negative 10 meters. Why negative 10? Because it is now traveling in the direction of negative y, downwards. So the vectors which point in the negative y direction are negative vectors. So S is now negative 10 meters, U is 15, A is negative 9.8, and we want to find out T. So which is the equation that we can use here? S is equal to, yes, tell me, S is equal to ut plus half at square, correct. So S is negative 10, U is 15, so 15t plus half into negative 9.8 into t square, which is 15t minus 4.9 t square. So 4.9 t square minus 15t minus 10 is equal to 0. Now you can solve this equation using the quadratic solver in the calculator. So that gives you two values of t. One is 3.6 seconds and the another value of t here is negative 0.56 seconds. Obviously, the time cannot be negative and hence the total time of flight is 3.6 seconds. So in this problem, keep it in mind that any vector that is pointing in vertically upward direction will be taken as positive and the vector that is pointing in vertically downward direction will be taken as negative. Okay, so let us come to the second problem here. A ball is projected vertically upwards from a point O with a speed of u meter per second. So the speed is u meter per second. The greatest height reached by the ball is 11.48 meters. Find the value of u and total time for which the ball is 5 meters above the ground. The two things you have to find out. So just make a simple sketch of this. Now since it is not mentioned that the ball is projected from any height. That means the ball is projected from the ground. So it will go to the maximum height, turn and come back. So now here the greatest height reached by the ball is given to you. That means the displacement of the ball S is 11.48 meters given to you. Then the final velocity of the ball, we are considering only the journey of the ball in one direction from the ground to the maximum height. So the final velocity will be 0 meters per second, and A, since the ball is decelerating, A will be negative 9.8 meters per second square. You want to find out the value of U. So, which is the best suited equation here? Obviously, V square is equal to U square plus 2AS. So, V square, 0 square is equal to U square, you have to find out, plus 2A, negative 9.8 into S, 11.48. So U square is equal to 2 into 9.8 into 11.48. So if you solve this, you will get the value of U as 15 meter per second. Now, in the second case, they have asked the total time for which the ball is 5 meter above the ground. So, say this is the height of 5 meter from the ground, and we have to find out the total time for which the ball is 5 meter above the ground. So, for this, we'll take S as 5 meters. Now, U we have got already in part A, 15 meter per second. A is negative 9.8 meters per second square, and you want to find out T. So which is the equation that you can use here? Yes, tell me. Since you have to find out T, that means you'll use S is equal to UT plus half AT square. S is 5, UT 15T plus half into negative 9.8 T square. So, phi is equal to 15T minus 4.9 T square, which gives 4.9 T square minus 15T plus 5 equal to 0. If you solve this, you will get two values of T. T1 is 0.38 seconds and T2 as 2.68 seconds. Now see here that both the values are acceptable. How? Because when T is 0.38 seconds, the ball will first cross 5 meters, it will go to maximum height, come back, and at 2.68 seconds, it will again come to the height of 5 meters. We want to find out the total time for which the ball is 5 meters above the ground. So total time for which the ball is 5 meters above the ground will be obviously the difference between the two times that we have got by solving the quadratic. So it will be 2.68 minus 0.38. So 2.3 seconds. Since at 0.38 seconds from the starting of the journey, it first crosses the height of 5 meters, goes to the maximum height, and comes back to the height of 5 meters at 2.68 seconds. So, the difference between these two timings is the time for which the ball is 5 meters above the ground. Okay, now let us come to the third problem here. A ball P is dropped from the top of a cliff. So there is one ball P that is dropped from the top of the cliff, which is 100-meter high. At the same time, another ball Q is projected vertically upwards from the bottom of the cliff with a speed of 25 meters per second. Now two balls collide. Find the distance of the point where the two balls collide from the bottom of the cliff. Okay, so let us make a sketch of this. Okay, so this is the cliff. This is of height 100 meters. Now, one ball is dropped from the top of the cliff. So this is ball P, and another ball at the same time is projected upwards. Say both of them collide at this point. So let us take the height of point of collision from the ground as x, and since the total height of the cliff is 100, this will be 100 minus x. So let us first consider the journey of ball P. Now the ball P is dropped from the top, so its initial velocity is 0. It is dropped from rest. So its initial velocity is 0. As it is coming down, it will accelerate. So A will be 9.8 meters per second square, and its displacement is 100 minus x from the point from where it is dropped to the point where it collides with the second ball. So let the time t be the time at which the two balls collide from the starting of the journey of the two balls. So, which equation will use? S is equal to ut plus half at square. Now in this case, s is 100 minus x, u is 0. So 0 into t plus half into 9.8 into t square. So we get 100 minus x is equal to 4.9 t square. So take this as equation 1. Now consider the journey of ball Q. For the ball Q, now this ball Q is projected up with a velocity of 25 meter per second. That means u is 25 meter per second. The point where the two balls collide is x meters from the ground. That means ball Q will travel the distance x before collision. So for ball Q, s is equal to x meters. Now here the ball will decelerate as it is going up. So a will be negative 9.8 meters per second square. And this ball will also travel for time t up till the collision. So again use s is equal to ut plus half at square. Now for this ball, s is x, ut that will be 25t plus half into negative 9.8 into t square. So x is equal to 25t minus 4.9 t square. Call this as equation 2. Now let us solve these two equations simultaneously. So from equation 1, we can write x as 100 minus 4.9 t square. Now this x you put in equation 2. So 100 minus 4.9 t square is equal to 25t minus 4.9 t square. This is from equation 2. So whatever x we have got from 1 in terms of t, I am substituting in equation 2. So on both the sides 4.9 t square cancels. So 25t is equal to 100. So t is equal to 4. That means from the beginning of the journey of the two balls, after 4 seconds, they will collide on each other. But we want the distance from the ground. So substitute it in the equation of x. X is what? 25t minus 4.9 t square. So that is 25 into 4 minus 4.9 into 4 square. So if you solve this, you get 21.6 meters. So the two balls collide at a height of how much? 21.6 meters from the ground. Okay students, all the steps are okay with you? Please go through these problems. Obviously we are going to solve more problems on this. we are understanding all the concepts properly. Keep it in mind that when the particle is projected up, it deaccelerates, so its acceleration is negative 9.8 meter per second square. Whereas if the particle is dropped down, when it is coming down, it will accelerate. So it will take A as positive 9.8 meters per second square. And all other vectors which are pointing upwards will be positive, pointing downwards will be negative. Okay? Have a good day, students. Bye.